The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
And good afternoon, everybody. Welcome to Advance Refrigeration Podcast. You're your host, Brett Wetzel and Kevin Compass. Are you doing actually anything today, or are you just dicking around today?
The fuck did you just say to me?
Wanted to see if you're...
Yeah. I changed out 6 E3s a day.
6?
Yeah.
What'd you change them from? What were they before?
E1s and an old ass E2 that might as well have been an E1.
Is that the one with the purple battery?
It was older than that.
What?
Yeah, it was old. It was like the firmware was like in the early 2s.
The one. I do have to say that.
Fuck off.
So besides changing,
I ran around like an idiot all day.
so did I.
Yeah, okay.
I did. When you get out in Colorado. By the way, if no one ever knew, you have to make a reservation at Casa Bonita. And that's like weeks out. It's not just a place that you can go. I don't know if anyone knows what Casa Bonita is if you watch South Park, but I thought I was going to go this week, and yeah, that might. Yeah.
Is that like a real place?
It is a real place, and they do have cleft divers and Black Bart's Cave and balloon animals and face painting and all kinds of other stuff.
Jesus Christ!
What? I want to go to Casa Bonita. I want to have the real Eric Cartman experience. And then gorge myself with a whole bunch of tacos. So, yeah. So I'm out in Colorado this week. I'm training, and I don't know, we're doing a whole bunch of basic refrigeration. Like we started, I'm going to get shit as soon as I say this. As soon as the words leave my mouth, you're going to give me shit. We started going over the refrigeration schedule first. So they understood like what the rack is supposed to be. You're laughing already. I see it. You going through the refrigeration schedule, so they understood, okay. It tells you everything about the rack. Basically, it has the BTUs per the cases, it has the line set sizes, the length, what the saturated suction is supposed to be, what the TD on the condenser is, and so on and so forth. And I guess that's what's going to lead us into what we're going to talk about today. Why are you laughing? I didn't say P&ID, did I?
Oh, you were thinking it.
No, I wasn't. Kevin likes to make fun of me because whenever like we're talking about anything, like he's telling me about some problem that he's having, I'm like, I want to see the P&ID, and that's so I can visualize like what's going on. And now every time I say it, I can't say it because he just starts perpetually making fun of me. So,
Not one time ever have I ever wanted the P&ID diagram.
I know, because every time I ask you, like, I don't freaking have that thing. What do I need that for? I just go do it. Be a man. You don't need an ID. So you want to do a start about basic case diagnostic? Like where you want to start first? Where, do you start there?
Yeah, let's do it.
So I usually if I show up for a case fault, the first thing I'm going to check is just look at the case. Maybe the store manager might be able to tell you some stuff. Maybe the department head might be able to tell you some stuff about what's been going on with it. You might get a little bit of history, right? This has been going on every blah, 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 every 2 weeks, every 3 weeks, whatever. So one of the first things you do is verify the temperature sensor, right? It could be something as simple as that. And if you verify that the temperature sensor is X temperature off, then already that might be a reason why. We found a case today that had a 5-degree offset in it. We have a 5-degree offset in the case. It thinks it's 5 degrees warmer than what it is. So that means it's going to try to pull down colder than what it is. And also means it will not terminate at the proper temperature. It will essentially terminate 5 degrees lower than what the set point would be. So that's why it's important to check that out first. Check out the frost pattern. See if there's something blatant. Like you might see, okay, we got a fan out. Guess what? That's probably the reason why. Then once I've done that, I have my next step. Did I miss anything that you would cover, Kev, or try to keep going?
Yeah, keep going.
All right. So after that, we go out to the rack. We want to make sure the rack is running the way God intended. The valves and everything else, the expansion valves, legal line solenoids, everything is going to be based off of what that rack is doing up topside. Some racks, so let's start with the suction first. Suction should be at set point and not with a deviation more than 3 or 5 psi. Now we're talking about regular HFC systems. If you have an older system that has the barbaric unloading where it's just unloading the heads, nothing's digital, nothing's a VFD, there's a little bit more deviation you can have in the set point. After that,
Did you say
barbaric? Yeah. Because we have all these fancy ways of unloading now, right? We have digital unloading, we have VFD unloading. So the old school way is barbaric and boomerish. All right, fine. Don't agree with me. I know. After that, we're going to check the condenser. This is really easy to do, especially if it's above 75 degrees. Most systems now are all doing floating head and essentially utilizing the TD on the condenser. Actually, a funny story. Today, we get there first thing this morning. It's 46 degrees in Colorado. And the minimum saturated condensing temperature for that was 75 degrees. And all of a sudden, the TD shot up to 85 degrees. And then all of a sudden went back down. And by the time I found where the ambient was, it was gone. I didn't know what the hell happened. There was an exhaust from a Resner heater for the dock that was just in line of the ambient temperature sensor. So if ever the heater went on, it would raise the ambient temperature sensor directly under the condenser and then raise the saturated condensing temperature set point.
Stop it. Stop.
I swear to I'll show you the picture.
So I had something like this. I'm getting an echo.
You're getting an echo?
Only when I talk. There it goes. It's better now. I had something like this with a CO2 sensor, leak detector on the Advance rack, and all the stack was like right there for the exhaust for the dock heater.
Hold on.
I don't even remember what we were talking about now.
I don't know. I'm going to throw the fucking thing in the garbage. That's all I know. That I'm so mad. I don't know if the mic is shot. I don't know. It's probably the freaking Zoom track because it looks like you're playing with a Tonka toy when it's just whatever.
All right, what were we talking about? Back to you.
No, we're going to talk about your ambient temperature sensor dilemma. Because I was talking.
Oh yeah, no ambient temp sensor, but we've had a couple like CO2 racks in a row, especially at Aldi, where the dock unit heater was setting off a leak detector because it would kick on and it would get like a slight wind and it would just put CO into the rack, and the rack the RLDS was picking it up right there.
I said it to you by accident. I meant to send it to myself so I could share it, unless you're on Facebook on your thing, because otherwise I'm sending the picture to myself so I can see it. Suit track piece of garbage crap. Present screen. Look at that shit. That's amazing, right? So what we're talking about, so most condensers nowadays, they do TD control. Example of the most medium temp racks have anywhere from a 12 to an 18 degree TD. Low temp racks anywhere from 8 to 12. And then basically a split header is going to be the difference of the two. Usually they're anywhere from 12 to 15. So what it does is it takes the ambient temperature and then says, okay, whatever the TD is of the condenser plus the ambient, that actually ends up being your set point for your saturated condensing temperature. So I go there this morning and the saturated condensing temperature says a minimum of 85. So it doesn't matter if, I'm sorry, it doesn't say a minimum of 85. It says the set point is 85. But then when I look at the set point, the minimum was 75, and what that means is if it's 40 degrees, 30 degrees, whatever, it's still going to try to maintain 75 degrees saturated condensing temperature. And it did it for a split second. And by the time I found where the ambient temperature sensor was, it was gone. And I'm like, I don't know what happened. So later I was up on the roof and I'm looking and I feel a little bit of heat when I was walking by from the exhaust here from the resident dock heater. And I was like, no freaking way. So essentially the exhaust is coming out, getting sucked up from the condenser fan. And so the ambient temperature sensor is drilled into the side of the steel and then right underneath this condenser. Temperature is just pulling in that air. It thinks it's hotter than what it is. And then it's going up in ambient. So back to what I was saying. So if you have a 10 degree TD and it's 70 degrees outside, then that means your set point would be 80 degrees saturated condensing temperature. That's essentially how that works. So the reason why that's important is because you can check when it's above 75 degrees, make sure the TD is working and make sure that we're not going above set point, because we're above set point, chances are we probably have some kind of other issue, whether it be a fan out block condenser or a heater blowing into the condenser, because that could be a thing as well, apparently. Funny. So there's that. Once you know that your suction pressure is straight, your saturated condensing temperature is straight, basically your discharge pressure and your liquid pressure, next thing to check for would be to go to see on the schedule and see if it has a subcooler, or look at the thing itself and see if it has a subcooler, because if it does have a subcooler, that subcooler is going to affect your valve size, also your liquid charge, and a whole bunch of other stuff. So we have to make sure that the expansion valve gets the right liquid that it was designed for. Same thing with the case piping, because Kev, what's going to happen to the case piping once we subcool that liquid?
It's gonna be too big.
It's gonna be if the rack was designed for a subcooler.
You said if it's not there.
Yeah, if it's not working.
It's gonna be too small then.
Yeah, so you won't have enough capacity of refrigerant going to your valve. So you'll see maybe one or two coils out of, let's just say four different coils run fine superheat, and then the other two will starve because the piping just isn't big enough, because now the refrigerant doesn't have the amount of BTUs that it once had. You know what I mean? Because it'll increase capacity on an expansion valve. Shit, that's like a half a ton on some instances, right?
Yeah, it's a lot. It's a huge difference. And it could mean that the difference between some of these cases come with like fairly tightly sized expansion valve, like some of these P&ID cases. If the subcooler is not working on some of those, they're sized so tight on some of those expansion valves, they may not make it.
Yeah, and that's another thing that happens too. Like if a lot of times if you don't know if the rack has a subcooler or not, and like you suspect, because what'll happen is you'll look at the expansion valve, you didn't know it had a subcooler, and all of a sudden you're like, it's starving. It needs a bigger valve, which in essence, if it wasn't subcooled, it would. So what do? You take those numbers, take the BTU load of the case, give it over to United, and tell them what refrigerant. They're going to ask for your delta P. They're going to ask for your liquid temperature. And if you don't know it has a subcooler, and they assume that it's 100 degrees, in essence, that expansion valve is going to be way oversized. And then it just exacerbates even more issues. I've had that happen with someone I was talking to. They ended up putting in A ports in something that only needed a AAA port, because they didn't know, the guy from United didn't know they had a subcooler. And so two of the expansion valves were freaking just eating up all the liquid that it could. And then the other two weren't getting jack all. When we went through expansion valve sizing before, we're not going to do that again right now. But in essence, that's something that you have to be concerned about. And that's why we spout it off. And the other thing is too, they put on a subcooler as well for equipment sizing. Right? You could essentially increase your capacity of your compressor by 25 to 27%. So you might have 4 compressors on a rack that have 100,000 BTUs apiece, gives you a total of 400,000. You might have a caseload of 450,000. If that's the case, your suction is going to struggle in the middle of summer. Your head pressure is going to be way higher because your suction pressure is struggling. And so by then subcooling it, now instead of having 400,000 BTUs across, now they have a 50-degree liquid instead of 100. Now essentially you'll have 500,000 BTUs with a surplus of 50,000 BTUs. It'll essentially be greater than your caseload. And then so that way, then they wouldn't have to put, because if they didn't have the subcooler, we'd have to put bigger compressors on there, do the same capacity. And then on top of that, now you'd have to install bigger line sets because now it's going to utilize more volume of refrigerant in order to do the same thing. And bigger solenoids, bigger expansion valves. Am I missing anything?
Yeah, it affects condenser sizing too. If you're shifting load between stuff, I've seen racks where the low temp barely makes set point because on the condenser side, because it's used to shifting like another 50,000 BTUs to the medium temp that it would be. Now it's worse off than it would be. That's a huge thing, is making sure the subcooler is working and making sure that your suction temp's not super high. I've seen this on racks, like where the suction temp is 50, 60 degrees on a low temp compressors, and you're running liquid injection the entire time, and now you're eating up compressor capacity. And that's a huge ordeal too, is making sure that suction's not burning hot. When you start doing that, you start eating up oil.
100%. And also premature fail on the windings, premature fail on the bearings, right? Because you're going to kill the oil, you're also going to kill the bearings as well. And so if you have a lot of stores like the old, I don't want to name out any names, certain stores, what they'll do is they'll put more compressor capacity on there. They'll put more his capacity on there, but they won't do shit for the condenser, right? So if we can reduce how many compressors that we have running by essentially giving the refrigerant more capacity, in essence, you could actually shift the load for the subcooler onto a medium temp. Usually what we try to do, it doesn't make any sense to try to maintain a saturated section of 40 or 45 degrees on a rack that's running minus 25. Makes no sense whatsoever. It's a lot of wasted energy. So it makes more sense to have your medium temp or even your high to medium temp. Sometimes like places like Whole Foods, they'll have a rack that's set for 35 degrees saturated. So they use that for a lot of their dry storage that still needs to be cold, but it only needs to be like 45 degrees and nothing that has to be down like in the 20s. And so they'll use that rack typically for the load for your subcoolers. And it's the same thing. They also use that rack sometimes for some of the racks that have their own air conditioning within the motor room as well, right?
Yeah, the motor room air conditioning by far, I think, is the greatest thing ever. Costco does it. It's awesome. Summertime, 90 degrees outside, motor room 70. It's nice.
70?
It's like in the 70s. Yeah.
Really?
Yeah. It's
all the Costco's I've ever been to are the old ones where it's the mezzanine.
Well, most of them are CO2, so they're dumping load for the low temp. So it's helping add some load for the actual, put some load on the medium temp side of it. It keeps the room nice and warm. I think the set one's like 75, but it's like super comfortable in there. And it's clean because there's no air coming in from outside, but it also helps keep the room clean and helps keep the equipment lasting longer.
You got you. No, I've never seen any of the newer Costco's. Like I said, used to do a bunch of them on the East Coast, but like I said, I haven't been to any of the ones where it's the new CO2 racks. Usually where they have their own penthouse. But so making sure the subcooler is working, and then once we do that, then we can go out to our case, right? We know we have the right section, we have the right discharge pressure, giving us the right delta P, and the right liquid temperature. The only complexity that sometimes you will add, in those places like Sprouts, Walmart, they also use what's called a liquid pressure, LPRV, liquid pressure regulating valve. And what that does is it gives the same temperature and same pressure to the liquid all year round. Because, and I know I said this before, but you'll hear some old timers say, I'd make seasonal adjustment on the space shuttle. And the reason why is because the delta P changes. You'll have a higher delta P. And what I mean by that is the difference between your liquid and your suction pressure. The higher the delta P, actually the valve appears bigger. So when you have a lower delta P, the valve appears smaller. If you don't have enough subcooling to make up for that, essentially what will end up happening is the valve might be, oh my God, so sorry, a little bit undersized. And so the guy will have to go in there and open up the expansion valve a little bit based on what it was. This way, if you use a LPRV, liquid pressure regulating valve, it's the same pressure, same temperature all year round. In that way. And I will tell you, the expansion valves, if they do have that, they adjust super, super slow. Usually you can adjust the valve within 5 or 10 minutes. You're like, oh yeah, I can make my next adjustment.
I love them. Like, I think that with those, you're able to tune in and superheat so much better. But I will tell you this, it is the most misunderstood valve and misdiagnosed valve there is on a rack, because people see low liquid pressure and they're like, oh no, it's like the Kool-Aid man breaking through the door, and they just open it up, and then it causes every valve in the store to flood out.
Not just that, but knowing the safeties that come in contact with that. On Walmarts, they typically have a normally open solenoid in parallel with the liquid pressure regulating valve. And the purpose for this is, what it's typically doing is we're controlling about a 70-degree saturated condensate temperature with a 50-degree liquid temperature. So if that's the case, we have 20 degrees of subcooling. If that temperature starts to delve up close to the 70 degrees, especially with a glide refrigerant, it'll actually end up starting to flash and like empty out the sight glass. I know of a rack where the solenoid wasn't working, so it was closed all the time, and they saw a sight glass flashing after the LPRV, and so they jammed copious amounts of pounds of refrigerant in that freaking thing, trying to get it to not flash. And yeah, it doesn't work at all. It gets exacerbated, and then all of a sudden you have liquid coming out your suction, and then you have a real bad time. So like I said, typically there'll be a bypass around it. So if the temperature does hit, it's usually, I think, 10 degrees within like what the set point is. So if the set point is 50 and it gets up to 60, before it actually gets to 70, it'll open up that solenoid and act like a regular conventional rack. And that's if essentially the subcooler would fail.
Now, this is where you start getting these nuisance liquid alarms, where like a guy will get there and then they'll be like, it's at 45%. And then 2 hours later, when the liquid temp comes back down and the liquid temp goes back up a little bit in the afternoon, where the subcooler is struggling, and it opens the bypass up again, and then it goes from 45% down to 10%, and then it's tripping the low liquid alarm. Then the guy goes back in the morning, and the same thing. It's at 45%. If that thing is cycling, your liquid lockout's going to be on, off with it. Because I've seen it back up a receiver as much as 30 to 40%. Especially if it's warmer out.
Yeah, making sure that's straight. That's the other thing too. If you're constantly it's not just the liquid temperature, but it's also the quality of that liquid temperature. You know what I mean? Your pressures are going all over the place. Your liquid's going all over the place where it's not tuned in, or the sensor is off controlling superheat for the heat exchanger for the subcooler. Remember, these things are not supposed to condense gas into a liquid. It's supposed to just bring the temperature down. It's only made for a sensible heat load. So if we're putting any kind of vapor within that heat exchanger, it doesn't really work well at all. Bad time. So making sure we do have our liquid temperature. We probably spent way too much time on that. Once we know that, then we can actually go out to the case once it's the ice, and then do my ABC method, where you check the airflow first. Hill Phoenix is great about putting the airflow on there. The airflow has become so important in a lot of these cases, because a lot of these systems now, they have the ECM fan motors in. Well, at 2 o'clock in the morning, when you're going to replace the damn fan motor, you don't have the correct ECM motor. So a lot of times people are just going to put in the basket fan, the rescue motor or whatever, right? And if you're not checking the airflow after, all you're worried about at that point is bringing the case down to temperature, all right? And so later on down the line, you might have an unexplained pressure drop because you're just shoveling too much refrigerant down the pipe because the expansion valve is stupid. All it knows is that it's supposed to control superheat. It doesn't know how much air you're throwing across that coil. So when you're checking the airflow, it has to be directly after defrost. Like I said, Hill Phoenix is real good about giving you the actual airflow.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
And feet per minute, if you're a boomer or someone my age, you probably have used the Alinor Jr. If not, you stepped it up to the Testo 410i. That works just as well as the Alinor. And please, none of the older cats yell at me, but it does. You're checking the airflow in feet per minute. You have a dimension in there that you can give it. If you're checking feet per minute through a circle or whatever, I usually do a 2x4 section. And that got it really close to what the Alinor does as far as airflow. And then once we have our airflow, the next thing is making sure that we have our SST. Now, before I continue with the SST, I will say Houseman is starting to put them in all their manuals. I've noticed that. I just wish Kaiser and Zero Zone would start putting the airflow in there. Because here's the thing, how do we know if we have too much airflow or not? The way I tell people sometimes what they'll have to do is, and it's only if you have more than one of those cases. If you have one case that's messed up and one case that's not messed up, go to the messed up case and see how much airflow that you're measuring off of that versus the one that's not working. And that's the only advice that I have. Kev, you have anything for that?
Yeah, that's what I do with it too. I've seen a lot of new cases here come with the plenums that are like just like absolute like falling apart, and like there's not sitting down. Like I see it all the time on construction, and they're not sitting down all the way flush, or like the sheet metal peeled out the side. Like it's just bad. So I carry foam with me. There's a lot of like on startup, I'll find air like leaking out the sides. Just make sure that the foam's all good with those, because a 1-inch gap could lose a lot of CFM out of it. So just like that, like Brett said, air before charge, checking all that. I don't know how many cases I've looked at where they've looked at it for years. It's been an issue nonstop for years, and it's got 300 feet per minute more than it should. Or it's too little fan, and they were supposed to be turned up from the factory, never did. Looking at the programming keys and using those and changing motor speeds. But you shouldn't be doing that unless you absolutely know that's the issue and you're not getting enough out of there. And like I said, Brett's air before charge. The other side of the air thing is air filtration, making sure you don't have something blowing into the case, because I've seen that time and time again where humidity issues or air filtration will actually cause superheat issues. Like you can't maintain superheat in the case if the humidity's like it is every day where Brett lives. If it's that humid all the time, that eats up your coil capacity. You're doing dehumidification instead of cooling. So it's eating up your coil capacity. So it could actually take and cause your superheat to be high to the point where the expansion valve's undersized, because it's doing so much dehumidification.
And air infiltration can not only just be air blowing into the case, but also what you have in the case. You got to remember, a lot of these cases are set up by what are called programmers. They set up the cases to what looks pretty. They don't care about operational stuff. So like you can have, they're like, oh yeah, we're going to put the 22-inch shelf up where the 12 should be. And I'm exaggerating a lot, but my point is that they will put shelves in locations that will essentially cause air to roll out of the case. And here's the problem. If air rolls out of the case, air must re-enter that case, because now the case is at a negative pressure. So it'll pull it from wherever it can. And typically it'll be the ambient air. And that's not what they're supposed to do. They're supposed to take the same air that's put in the case and just recirculate with a little bit of loss, not 50% loss. And they have a smoke pen on Amazon. They also have some kind of electronic tool. It almost looks like one of those electronic mod cigarettes that you can take a big hit and blow into the case. And then you can see essentially what the airflow, what the air curtain's doing. And airflow is also the honeycombs, and sometimes there's diverter metal pieces within the actual case, either in the flue up at the top or sometimes even in the back.
I hate those because they're never in they're never in the same spot, like in cases, and it's like always a crapshoot if it has it or if it doesn't have it. But no, it's making sure that the case is clean and those honeycombs are clean, and even like the sensor placement. So we've been doing a lot of EMS changeovers, and I've been having the guys install a lot of sensors. When we do sensors, I'm not ripping a case apart, putting sensors in. I'm drilling a hole top and feed it in. Like, we're not going to rip what? We're not ripping apart an entire case to put a sensor in. It would be like 4 hours.
I know. Vegetables.
Yeah, so you got to watch in these newer Husband cases. They're and same with Hill. There's 2 air bands in there. So there's an air band for anti-sweat, like anti-condensate band in there, and like the Husbands have a dead spot. So if you don't drill all the way through, and when I'm drilling through, I'm making sure I hit the deck pan. You just got to back off because the metal's kind of thin. So making sure you hit the deck pan and you get the sensor all the way through, and it's not in that first air band.
I got to get a cutaway of that because that's really interesting. Because you know where I learned about that? When I was still doing service, Greggy called me.
Doing service.
He said, is there some kind of problem that I don't know about with the S3Cs where they read off like 8 degrees, like, and every single one's doing it? I'm like, no. So I stabbed one of the honeycombs, coincidentally on the Husband cases, right? Because you all have one set over here, one set over here, different coils or whatever. And I stab another one, but I don't stab at the same exact location. I stab it an inch closer to where it is. And all of a sudden I'm reading 8 degrees off. I'm like, how the hell does that work? If you pull it down, there was even though you have 2 inches of wide honeycomb, one was that anti-condensation flue plate thing, and the other one was the actual discharge air. So,
it's, and they even mount the sensors. So if they're mounted to the front of the honeycomb, which I tend to not do because then people go to clean them and it turns into a nightmare. So if they're mounted to the front of the honeycombs, especially the Hill ones, if you don't mount it in the right spot, it ends up in that dead zone. Aldi, same thing with the Husband ID cases. If the sensor is too far forward, it's in that dead zone, so it reads off. I don't know how many cases I found that the sensor's just in a wrong spot. And if you move it back a little bit, it's like a 4-degree difference.
Which one are the Husband multi-decks? Husband
ID, they're ID5 SUs or SLUs and ID6 SLUs, I think. So those are the cases with that like false. They don't have a fan in there, but it's like a false back in like the top.
If anyone's ever worked on the horrible,
open the triple decks,
the open deck, 3-fan, 3-section frozen food open case.
I have never had my ass kicked more than working on those cases.
Sure.
Oh, those cases will get you every time. I've had ones where people put the wrong fan motors in the secondary, the wrong blades in there, and they just do not work. The superheat's high, and you have 2 different coils in there, and one's a dehumidification coil, a pre-cooling coil, and the next one's your actual freezing coil. And then sometimes, like the Husband ones, the secondary fans go backwards and defrost. What an awful idea.
It'll make you want to punch kidneys.
It's bad. Or when they ice up and the secondary fans fill the cavity full of water.
Yeah, it's not good. Not good. See, they don't show. What's weird, I'm looking at the side profile of this, and it doesn't really show.
It doesn't.
No.
You definitely can feel it when you're on top of the case, though, because you feel like you're about to fall through.
Yeah, I don't know. I'll keep looking for a little bit. Back to what we were saying, air infiltration can be anything, wrong fan, shelves being in the wrong location. So make sure we're checking that. So if everything is all right with that, the next step is to probably check your SST. Making sure that you're at the SST that's designed. And if not, and what I mean by that is, so if the TD is 4 degrees, and the case temperature set point is 34, then that means you'd have a 30-degree SST. Sometimes someone get overzealous with the EPR and slam that thing all the way down to 15 or 20 degrees saturation. And when that ends up happening, we talked to Dale about this. Remember, we were like, yeah, those specs, those are just suggestions if we're working at the actual SST. But as soon as we start going lower than that SST, all bets are off. And then you're going to start adhering more moisture. And now you're going to have to extend the defrost. We had to do it today. In case we were working on the doors on. And we're going to go look at it tomorrow morning. But they had, the rack was running at, I think, 18 degrees or 15 degrees or something like that. They had that EPR pegged out. So the saturator was super, super low on there, and just everything was icing up perpetually. So we raised it up to where it needed to be, and we're going to see what happens. But we had to extend the defrost for that very reason, like as far as length time, because the whole month before, it was never, ever getting down or getting up as far as termination temperature.
I've seen glass door retrofits where like they're as long as an hour and a half.
Fair enough. But that's not what's in the book.
There's no, the book is 30 minutes. It's out the window. But I've had cases where it's as long as an hour and a half. And the problem is if you don't have it set like warm enough, you're done. It's not the frequency of defrosted glass doors. It's getting it up to temp and just getting it done. I don't think those glass door retrofits ever go. They just ruin the cases.
The problem is the spec is whatever, right? And then you have to extend the defrost because now you're not getting that ambient curtain that was there. You're not getting that little bit of infiltration in that you once were. And, we've said this before, you'll lose upwards 75% of the capacity. And that's the other thing too. So like, I think what happened was on these cases, because we were doing the map today, where it's 11,700. It was like, 11,208 BTUs for the whole 8 foot. Okay. You split that in half because a husband 8 foot has 2 coils in it, right? So then you have 5,000 something, right? Then if you have to then minus 75% off of that, now you're down to AAA, and they had a AA.
Because a lot of customers aren't changing the valves or the fans because you need less fan airflow too.
Doubtful they did that. Highly doubtful they did that.
That's a huge issue. The only people I've seen do the glass retrofit doors is Whole Foods. Like they'll go in and they'll change all the fan motors, all the expansion valves, the riser piping, and redo it that way. It's a huge cost. You're saving a lot of money, but like at the end of the day, if you don't do it the right way, you just made this somewhat not working case.
It becomes a service issue nightmare because then now you don't have all the specs of what that thing should have been.
Well, the problem is that you got these like trunk slamming door companies coming in, and they're selling door kits for all these cases, and they have the door kits, but they don't want to pay for the refrigeration side of it. They pay the guy to come in and adjust the EPR and maybe set the superheats. They're going to be hunting all over the place. Especially the Hussman cases, it's bad when they do it on those because those coils are so efficient. And then if they don't put the right size expansion valves in there, they hunt all over the place because it's such a little load.
We were having that issue today, setting superheats. We were de-icing all the cases. And basically, we had a little bit of hunting on 1 or 2 of the valves. And I'm just like, let's see where it ends up. If it becomes real drastic, then we'll make the decision that we'll decrease the cartridge within the expansion valve.
And then I found like when they do those is we've had some like lazy like liquid pooling in like the suction side of it. You got to bend the suction line up a little bit on the coil side so it has kind of like a inverted trap almost, so it can't roll from one coil to the other.
Oh, the oil.
Not the oil, the refrigerant. If you get some little bit of liquid from the hunting, so say the far left coil hunts a little bit as it's coming back down the suction line, and if it's not pitched 100% from Hussman in the line right, and say it pitches back a smidge, that liquid rolls right back down in the next suction line. And it boils off and causes that valve to shut down.
I wonder if there's any documentation by anybody that tells you a procedure for what needs to be done. So yeah, we know that the capacity cuts down by 75%, but like How
I'm
much
sure
technically?
if you bought Innovator doors from Hussman for their cases, they're going to tell you exactly what needs to get done. And I'm sure if you bought Anthony doors from Hill, Envision doors or whatever they call them from Hill for their cases, I'm sure they're going to tell you what needs to get done, but they're not going to tell you what needs to get done on these random door manufacturers that they aren't going to be able to tell you.
I think I found it. Let me just show this real quick. Is this it? Because it just looks funny. So you look like you have two plenums here. You have the one plenum at the top
Yep.
and one plenum at the bottom. And so you have this plenum right here that has nothing. And then you have this plenum with a coil. Yes, because you have to have, does the sensor have to be farther out or in? I forget.
It needs to be farther out.
Yeah, so this would make more sense. So the air basically, yeah, so your sensor would have to be over yonder. Otherwise, you're getting this other secondary plenum crap that's here, that's separated by this piece right here. Yes?
Yes.
Okay.
Yes.
I knew it was in here somewhere. I just couldn't remember where the fuck it was. All right, so we got that. Cool. All right, never mind. So that's done. Then after we know that we have the right SST, the SST has to be at or within typically 3 degrees under what the case is called for. Otherwise, you're going to have to extend defrost. And if you go really low than that, it's going to affect your whole coil size, but it's a whole nother discussion. Once we know that we have our airflow, our SST, the only other thing that could be messed up for that case, we've already checked the filtration, all the other stuff. So the only other thing should be superheat. And we've already verified that we had the right liquid temperature. We already had the liquid pressure. We already verified that we had
Good ambient conditions, not a lot of humidity.
So, I mean, the superheat wise is either going to be some kind of blockage, whether it be in a filter dryer that's inside the case, which is Kevin's favorite thing in the world, or we have a block screened within the expansion valve, or an inadjusted valve because someone wanted to monkey with it before.
Or hold up here. We got the last one,
Ooh.
the plug distributor orifice.
Mother of God, why does it happen?
So I've only ever seen this at one store, and it's Target. I've only ever seen that like gunk they get. You know what I'm talking about, right? Like the stuff that gets in the gunk on the Target expansion valves on the P Fresh stores. It's only the P Fresh stores, the wax. And like it builds up after a while. And then sometimes on the smaller, usually the 2 and 3 doors, it builds up in the distributor orifice.
It's almost like a tan
Yes.
wax.
Yes, it's a tan wax.
It's usually, honestly, what I think it's usually because of the freaking overheating of the compressors, and then when they short out, because when they short bad. We had one that shorted out three compressors all in a shot, and we ended up having to. We did, I think, 4 coalescing oil separators. Like, it was so bad, the wax in there, it actually built up on the check valve. This is what we found it, and on the check valve on the split, and it wouldn't split where the shit. I even tried heating up the check valve to try to melt the wax and then clean it up. I ended up having to replace it. So I replaced it. After I replaced it, then I took it apart again to see what happened. And then I heated it up to try to melt the wax and then wipe it out and then put it back together. And then third time, I was like, you know what? I'm done with this check valve. I'm just going to replace it.
So when I'm generally like checking like screens, I'll close the hand valve, pull screen real quick. If the screen is clean and the valve is feeding some, it's not the power head, because if it was a dead power head, it wouldn't be feeding at all. So it's not the power head. So generally once that happens, it's getting the pins pulled. And if I pull the pins and the pins are moved freely and look fine, then I'm on sweating the valve and I'm going to take the valve out. But I'm going to look in that distributor orifice, because 9 times out of 10 at that point, there's usually something in the distributor orifice, or I have a liquid restriction coming into the valve.
So one thing I will add to that, one thing I think should be done is putting in on any hot gas line, because usually the P-Freshes are typically hot gas, right? Most of the targets are. I don't understand why we filter the liquid, we filter the suction, but we don't filter the discharge. So
Andy went back and forth with this. Remember, it was a temperature rating.
So yes, on the dryer that's going to take out like actual, whatchamacallit.
It was all of them though.
No, I think the element style, like the one that they use on the suction, at least some sort of filtration.
I agree.
I know You know what I mean? Because then you're not going to reconstitute any moisture back into the thing. But if you have some sort of element, not the liquid desiccant, or not the desiccant for like the liquid, because that would the whole temperature range, because you're essentially going to regenerate it and throw the moisture back in. But if you were to use like a suction filter element where you're just catching the shit before it goes out there, the particulates of wax.
You know, it would be nice, the Sporlan, that 4 millimeter filter, or like the, I think it's, I don't know if it's 4 millimeter, the real thin,
The 4
yeah,
micron.
yeah, the 4 micron long filter with the socks. I think that would clean it up more than anything. And it's not something you would leave in there all the time. Like you would run it for a while and just clean it up and get a dirty rag cleaned up, just like changing a coalescent oil separator filters. It's going to clean it up eventually, but I just don't, that wax gets moved around from that hot gas and it just gums up all the expansion valves. That's why I'm not a big fan of having dryers at cases, because it just prolongs the thing and ends up slowly decimating the performance of everything as it goes along. The longer the dryers that are plugging, the less performance you get out of the cases, and then the worse off the rack gets.
And usually when does it happen?
2 a.m.
Find out at 11 o'clock, midnight. You know what I mean? It's never throughout the day.
Who wants to drag torches out at 2 o'clock in the morning? I don't.
Sure shit don't.
You know? Yeah, I don't want to drag torches and a vacuum pump and all my stuff in there while the manager's sitting there huffing and puffing while they got to pull a case. And yeah, no, that should wait till the next morning. I'd rather just close the hand valve, clean the screen, and go about my business.
100%.
But no, that wax is a huge issue. And then just following that air before charge thing is a huge thing. And then making sure you got the right size expansion valve. I don't know how many like gas changeovers I've followed up behind and they got wrong size valves and stuff. So just pay attention to what's in there and don't go off of it. If it's a Q valve, don't trust the last guy that put the tag on there, because that happens all the time. Like people put tags on there, they're building all these valves, and these guys may not know exactly what they're doing. They're just building a bunch of valves and they're grabbing them, and they may have tagged them wrong. They had the wrong cartridges.
Or they get the liquid sizing from the cat at United, and the guy from United didn't think those guys, a lot of them, any supply house really, they're going to be like, oh, it's air. You know what I mean? And maybe it's not, but they're always going to do 100-degree liquid. Ooh, I found the sock. Hold on. Found the sock. Yeah. So that's the sock.
Don't let supply houses size things for you.
No, never.
Because at the end of the day, you're on the hook for it, not the supply house.
100%. There's a sock that Kevin's talking about, that one that rack that I told you where we burnt that out, where it changed the coalescent low separator like 4 times, 5 times. That sock we also changed out numerous amounts of freaking times. And that actually prevents, because the wax initially blew out this right here because it was so bad. So we had to buy this assembly here. Actually, we ended up buying a whole filter dryer because to try to get this assembly, I don't know part numbers.
It's hard to find. You're better off just buying a whole canister.
So that's what I did. I bought the whole canister, but I knew that the wax was going to end up penetrating this. So I was like, fuck it. We bought a bunch of socks to slip over this. So then the wax essentially hit the sock rather than hitting the metal, because then you'd have to heat up the metal in order to melt that shit out.
So I did a rack with one of those, and it was a dirty R22 converted to 407A, and it was scrolls. They got converted to recips, and they were killing them, the scrolls, before that. That sock made it 6 hours, and it had a 30-pound drop on it.
Holy shit.
Yeah. And if you really want to get into it, Westermeyer makes a filtered oil reservoir. That thing cleaned up those racks better than anything. Like the oil,
go through there,
because every bit of oil has to go through that oil reservoir, and it was one more line of filtration on there. So filtering the oil is the biggest thing. Like keeping your oil clean is the number one thing with these racks. If you keep the oil clean, you're going to keep all the cases from plugging up. And the oil breakdowns where 90% of this dirt's coming from.
Where is it coming from? It comes from heat. So keep the compressors cool, man. Yeah, that goes back. You're a little bit more liberal than I am. I think about 30 to 35 degrees of super heat. You're like 20 to 25.
Keep them cool. Keep them happy.
I think it takes one evaporator fan failure to get you down.
It's not flood until it hits the oil pump.
I'm dying on that hill. Sorry. All right, man. That's it, right? Unless you want to add none?
No, it's good enough for now for a random talk.
Talk to you guys later. Have a great day.